Is it 10 o'clock already? So I guess we can start. Welcome, everybody. Thanks for joining here. This is the start of the session today.
Yeah.
And this one is about electric expansion valves. I guess that's why you are here. Now I need to figure out what I need to do. Press that button and then it works. So as you've seen in the program, this is about electric expansion valves. And as you can see, I'm from Danfoss, so you will get a few examples of Danfoss valves, however, some general information as well. And when we talk about the electric expansion valve, it's not only the valve only, it's always a complete system. And the system consists of the valve itself, yes, but then a controller and two sensors, at least two sensors, a temperature sensor, a pressure sensor, to be able to calculate your superheat. So it's always that complete system. Only the valve would not work. You need that complete system. And typically there's even more around that. So maybe there's a battery backup, maybe there are other things, a programming tool and so on. So this one shows what can be around that to operate the valve, to set up the valve, to have these programming copy tools and so on. However, what you build into a refrigeration system is really the valve, the superheat controller and the sensors. And then these valves are available in different sizes, of course. And that's maybe why you are here, in different technologies. And that's what I would like to talk about here. There are valves which are so-called PWM valves, which stands for pulse width modulation. And there are stepper motor valves. Let's start with the PWM valve. An example is the Danfoss AKV family here. So the one on your left-hand side. That valve acts like a solenoid valve. It's opening and closing, opening and closing, opening and closing. It's doing that quite often. For example, every 6 seconds is one cycle. So when it's 3 seconds open, 3 seconds closed, you are at half the capacity on average. When it's 1.4 seconds open and 4.6 seconds closed, then you do the calculation yourself, your percentage, right? But that's how it works. So if it's 2 seconds open, 4 seconds closed, you are on 1/3 of the capacity. So it's really averaging out, just opening, closing all the time. The other technology is the stepper motor valve. You have a stepper motor and you turn that stepper motor, that turns a spindle, and then a needle or a cone is going up and down, opening and closing the valve. That's a more steady flow. So now you might wonder why the two technologies and which one is better. Well, there is no better. Both exist in the market. But there are some positive points and some not so good points, as you always have that in life. And it depends on what you want to do. There are many more criteria. I just wanted to show these 4 here, comparing these two technologies. If you have that stepper motor valve, continuous flow, compare that to the PWM valve that is opening and closing all the time. So if we go to the first point, the simple electric connection, the valve that is only on, off, you have 2 wires, that's it. You power the valve, it's open, you depower the valve, it's closed. That's it, very simple, 2 wires. The stepper motor valve needs 4 wires to be able to rotate the stepper motor in the direction you want. So it's not really very much complicated, but you need to make sure that your 4 cables are in the right position. It's a bit more sophisticated. So in that respect, the PWM valve is easier. Now if you have a system with only 1 evaporator, then the valve that is opening and closing generates pulsations in the system every time you open it, every time you close it. The stepper motor valve is steady at one position. You have a steady flow, no pulsations. So that's a bit better there. Now let's have a look at a system, for example, a supermarket where you have 20 evaporators. Now if you have this pulsating valve on each evaporator pulsates a little bit different and they average out in general. So the power pack does not see any pulsation. There's a really pretty steady flow because they even out as a mix. So the more you have, the better it is for the pulsating valve. Of course, the stepper motor valve works as well there. And now we come to a positive point for the PWM valve. That's when you have a power failure. This valve is like a solenoid valve. A power failure, it closes. It's closed all by itself. You don't need to do anything. The stepper motor valve at a power failure stays at the position where it is. It will not move. So you need a battery backup to make sure it closes. You have to have enough power to close the valve in the case of a power failure. As mentioned, there is this PWM valve, the Danfoss AKV family, and I would like to show you that family. The title of this presentation says for natural refrigerants. They are available for natural refrigerants, for example, CO2, ammonia as well. Of course, you can get them for HFCs as well, but that's not the title here. So you can get these valves for CO2 and ammonia. And now I would like to come back to this pulsating thing I mentioned. When you open and close that valve, you get a pulse in the system. You get a pressure peak in the system whenever you close that valve. There is now that soft pulse technology that Danfoss developed where we dampen this pulsating effect. So we take a lot of this pulse away. Not completely, just to mention that. But we dampen this effect a lot, and you see that in the red circles. The former technology, the older valve compared to the new one, where we take the pulse away a lot. You still have an unsteady flow, a flow and a no flow, a flow and a no flow. That's still going to be the case, but the pulse is going to be taken away on these new AKV valves. When we go now to the stepper motor valves, again, natural refrigerants. Well, CO2 and ammonia. Yes, they are available for CO2 systems and ammonia systems. Large capacities even, especially for ammonia, very large capacities, up to the very high megawatt range. For CO2 systems per valve, still a really high capacity here. But then what about propane and so on? Well, we come to that in a second. I just would like to mention one thing more, especially on these large valves, which can be used for CO2 and ammonia. They have a so-called magnetic coupling. So the motor can be taken away without opening the refrigeration circuit. So you can change the motor, you can take that away. You can use a magnet to turn it manually if you like. You do not need to open the refrigerant circuit. That's a pretty interesting one. And then I promised something about hydrocarbons. Well, here's an example, R290, the hydrocarbon that is quite often used in refrigeration systems, a lineup of the Danfoss portfolio of valves. ETS valves, that's called the ETS series. So a lineup of valves for propane. And here you see the capacities. So even there, you can reach pretty high capacities per valve, and you can build small systems as well, down to small capacities. So whatever you need can be covered with these stepper motor valves. And then the valve up there, ETS Colibri, it's called. That looks a bit different to the other valves, and maybe several valves you might know. Well, the reason is, and here's a cutaway, that this is a fully hermetic valve. Everything is inside, motor, everything. So it's completely hermetic, that valve. That's in the market for a long, long time already and is really well approved in the market. Just to mention that this is a valve that is fully hermetic. And now a bit more into some more technical details of valves. There are different flow curves available in the Danfoss portfolio. There is the so-called linear curve. That's pretty understandable. It's almost linear. It's a line. And then there is the so-called S-curve, or if you want to call it polyline, fine with me as well. The S-curve, the idea is that per step, you only have a small change in opening degree in the beginning, so that you have a pretty good control at low capacities. And then when it gets bigger, you do more opening change per step, but to have a good capacity control at low capacities. That's the idea of the S-curve. And depending on what you want, you can choose which curve is better for you. The linear curve is pretty simple, because if you want to open 60%, you go to 60% of the steps. The S-curve doesn't allow you that simple calculation. So you need to make sure that your controller is doing that in a good way. But the controllers don't really have a problem with that. They can be adapted, no issue. But you can choose these curves. That's one point I would like to mention about curves. But there is another one. You open the valve, you close the valve. You open the valve, you close the valve. You want to have that these two actions are pretty much the same. So the difference between these two actions, between the opening degree when you do steps in the opening direction or do steps in the closing direction, you want to have that the difference is small, the so-called hysteresis is small. And that's what you see on this picture here. That's a small hysteresis. I've just put on the left-hand side, I've put a dotted line. That's the line that you do not want to have, right? That you would have in one direction, the line you see, and the other one would be the dotted line. That's what you do not want to have, because that's too much of a difference and your controller goes berserk, because it cannot really figure out what's going on. So you want to have a small hysteresis between these two lines, very close to each other. This is for the polyline. If we look at the linear ones, you see kind of one curve. They sit on top of each other. That's a zero, really, in fact, a zero hysteresis. Now, in the beginning, I mentioned that's always a system, right? You have the valve. We talked about that. You have the controllers as well, and the sensors. I will not talk too much about the sensors here, but the controllers. You need controllers here, so superheat controllers, where the sensors are connected. Danfoss has a range of different controllers, starting from a so-called driver only, where you give a signal from your main controller and tell the driver, open the valve. And the valve makes sure, the driver makes sure that it gives the right signal to the valve to open to a certain degree. Or you choose a controller that has the full superheat control algorithm incorporated. Both are available. And then there are controllers where you can operate one valve or two with the same controller. Your choice, what you would like to have.
Maybe.
If we talk about the PWM valve, so the Danfoss AKV family, there are controllers as well. Of course, they are somewhat different because they don't control the stepper motor, they control the pulsating valve, the on-off valve. And again, you have different choices for these controllers, with Bluetooth, without, and so on. If you have further questions about that, come to the Danfoss booth in Hall 7. We are happy to discuss that with you.
And good.
Final slide, or final information, talking about the superheat control and the algorithm. Well, there is the possibility to have different superheat control algorithms. A simple one is to have a fixed superheat, always the same, no matter what. That's on your right-hand side here. But then you lose some efficiency, because at low capacities, you see that blue area, which is called wet. That's how small you could go in superheat control, in theory. But with a fixed superheat, you lose some efficiency because your superheat gets kind of too big at low capacities. So that's why the Danfoss controllers have a self-adapting algorithm called MSS, Minimum Stable Superheat, and they figure out how low the superheat can be by themselves to be stable, to have a stable operation and to have a more efficient system. So if you have that in the controller, you can choose this algorithm. That's one of the four, just to mention that, just to explain this here. Well, and if you need to figure out which valve fits into your application and how to do all that, there is a software tool from Danfoss called the Cool Selector, where you can pretty easily select the valves. You can have a calculation for a complete cold room, for example. There are a lot of other interesting tools which are not necessarily related direct to electric expansion valves, but that's stuff you can have a look at as well. That was my final slide, so thanks a lot for listening here. And if you have questions right now, please feel free to ask. I think we have a few minutes left for questions. We should have 4 minutes left for questions. If there are no questions now, as mentioned, please come to the Danfoss booth if you want to have a deeper discussion here. And I see Christoph sitting there already. You're the next guy, all right? So thanks a lot. And you're looking forward to an interesting presentation from Christoph here. Thank you. Have a good day.